What's up, everyone? This is LeetCode 105. Construct a binary tree from preorder and inorder traversal. Basically, we're just given preorder and inorder traversals for our inputs, and we have to create a binary tree given that. Okay. Now, of course, preorder traversal is you handle the root and then the left and the right, right? So 3, 9, 20, 3, 9, 20, then 15 and 7. Right? In order, it means we go left first. So we would do 9, 3, 20, 15, 7. Or sorry, yeah, 15, 27. Um, so in terms of how we're gonna handle this, okay, I actually recorded this video already, but I had my volume was too low, so I'm gonna go a little quick because I don't want to spend like an hour because I have to make a C++ video. So I'll try and explain this pretty well though. Okay. So how we're gonna basically approach this problem is we're going to go through preorder, right, to find a root, what our root should be, and then we're gonna find the root in order. And if you'll notice, when we find when we grab this 3 here, right? We're going to find this 3 in order as well. But when we find it in order, everything to the left will be in the left subtree, and everything to the right will be in the right subtree, right? So that's an interesting observation. Let's use that to our advantage. Okay. So, given that fact, we can basically recursively keep calling this function, keep calling a function to basically build out the subtrees, given that we found that pattern or that observation. Okay, so that's really what we're going to do. I mean, kind of at its core. But we do have to set up the problem a little bit, okay? So first of all, when we get a root, right? Like let's get a 3 here. The 3 is not going to be at the start for in order, right? It can be anywhere. Like meaning it won't be at the start. Or like when we get this 9, right? The 9 is here, but when we get this 20, it's actually all the way over here. So we don't want to, every time we get a root from preorder, we don't want to linearly scan in order every single time, do a linear scan to find the root, because it'd be inefficient. So to optimize, let's use a hash map for fast lookup purposes, right? So that way our solution is not O of n squared. So we're just going to build out a hash map, and basically the index is just going to be the value in the hash map. The key is just going to be the actual, the key is going to be a value, and then the index, wherever it is, the index of in order is going to be the value of the hash map, if that makes sense. Okay. So I'm going to say the length of in order, right? Again, this is just for fast lookups, right? So don't get overly confused or anything. In fact, I think the solution is actually pretty simple. It's just understanding it is maybe a little hard, but I'll try and explain things, okay? We're gonna make a function. We'll call it recurse in order, right? I'm gonna have to call this at some point. Okay. So we're gonna recurse in order. We're gonna have to have a left and a right. And for our base case, right, if the left is ever greater than the right, we can just return. Now, the reason we need this is because we obviously can have null nodes. Like when we're at the 9, we go left to right, those are going to be null, right? So we need to basically make sure we don't get caught in a loop, infinite loop, right? So we need a base case to break out. Okay, we're going to say non-local current, and let's create that up here. Oh, we already did. Current really, instead of using a for loop, current is basically just the variable that we use to traverse through preorder. Initially it's at the 0th index, that's why current is 0. Okay, that's all current is. Because we're not basically handling all these in a for loop. We're just going to use current and then call preorder and preorder of the index current. Okay, so we're going to say root is preorder current, right? Let's get the root, and then let's find that root in order. So we're going to say mapping root. And before we actually call this, let's increment current. Okay. So what we're doing here, right, is let's get the root 3, right? We're just using preorder current, right? Current is 0 initially. So preorder of current to get the root 3. Okay, and now let's find this 3 in order. So let's basically find where the root is in the map, in the hash map. And again, this is just for fast lookup, right? Don't get confused. And the reason we're calling this variable middle is because when we get this 3 here, it's technically the middle of the binary tree so far, because everything to the left will be in the left subtree, right? Everything to the right will be in the right subtree. Okay, that's why we're calling it middle. And given we know what belongs in our left subtree and what belongs in our right subtree, basically that defines the windows for these input parameters when we recursively call the function. Okay, but before we recursively call the function, let's actually create this node in the tree node, right? So we're going to say tree node of root, right? Initially it's going to be 3, right? That's going to be, because again, we're building this tree top down rather than bottom up, because, well, bottom up would be just really complicated. Obviously much simpler, just start at the top and go down, because there's only one node, right, to start with. Okay, so now when we go left, we're going to say node.left, and again we're using recursion, right? So we're going to say recurse in order. Well, what should our left be for when we're going left? Our left should be whatever left is initially. The right is what's going to change, which would be middle minus 1, right? Because when we're at this 3, if we're going left, the right window would shrink, right? Because we want to keep handling everything to the left, so left is going to remain unchanged, but the right is going to change because none of these values matter for the left subtree, right? Same concept for the right. Right, when we go right, the left is actually going to be middle plus 1, and the right is just going to remain as right. Okay, and yeah, that's pretty simple. Seems so. Now, for our input initially, we call this function. It's just going to be length of Inorder minus 1 is the right window, and the left window is just 0, right? Because we want to look at this entire thing at first, right? So it's basically the code. Don't believe I should have any errors. So, yeah, I know solution might look a little complicated, but really just keep in mind, we're basically iterating through this, right? We're using current to kind of traverse it, right? That's what, right? So current, the initial index is 0, right? And the the way we find whatever the current is in order is by using the hash map, and then we basically add that to our tree, and we look at the left subtree and the right subtree. Okay. Yeah, should be it. Shouldn't be too complicated. I do think it's a little hard to come up with on your own, but I hope this helped. I mean, I think the algorithm isn't too hard to understand. But I will be honest with you, like, this problem really did confuse me at first, so like, if you need to rewatch the video or just look at the code for a little bit more, that's fine. I do think this problem is actually a little confusing, because it's very strange to be given 2 ordered list and construct a binary tree. I think this is a rather strange problem. It'd be very hard to solve this if you've never seen a problem like this, I think, in an interview, at least for me. But anyways, I hope this helped, and I'll see you in the next one. Peace out.